Hi guys, welcome to today's lesson. Pearson the science teacher. Today we want to look at the difference between distance and displacement. It sounds simple, right? But as we keep learning today, we're going to discuss and find out something that we might have not known. So before we delve in it, great. Thanks for sticking around and for following those instructions. So now we want to look at the difference between distance and displacement. Let's start with the definition of each. All right. So distance is that's the total length uh, traveled by an object. All right. Total length of the path taken by an object as it travels or as it changes in position. All right. So displacement, on the other hand, is the shortest length traveled yet in a specific direction. All right. So the difference between the two, one of them is one has magnitude and direction, that is displacement, while distance only has magnitude. It doesn't have direction. That makes one of them a vector and the other one a scalar. So in this case, we know that a vector quantity is a quantity that has both magnitude and direction. So displacement is a vector quantity. A scalar quantity, on the other hand, is a quantity that only has magnitude and not direction. So in this case, distance is a scalar quantity. Please bear with me. I'm going to talk to my dog in a short while. Let me just finish this. I don't know what's wrong there. Okay, so let's continue. Uh, Positivity and negativity. Here, we don't try to mean anything complicated. What I'm just trying to say is that distance, allow me to present uh, distance. Let me change the color. Okay, so black. So distance. Okay, distance is always positive or zero. All right, that's distance. Distance is always positive or zero. On the other hand, displacement, allow me to represent it by x. Displacement can be negative, can be positive, and can also be zero. So that's the difference there. One of the differences. I need to write positive clearly. Positive. All right. So that's another difference of them, so, between them. So distance can never be negative, but displacement can be negative, positive, or zero itself. All right. So let's proceed with an example here. All right. So okay. So I want to give this practical example. Let's assume this circle here represents my destination, and the point that I'm currently aimed is this point. So I want to go to that point, and I want to assume there's a stream here or anything, and here there is maybe this is a church or something. All right. So when I start off from here, I'm going to move, and I'm going to move like this, and boom, I'm there, right? If we had to add, if we had to add the distance that I'm going to cover as I move from point A to point B here, that length is going to be distance. All right. Yeah. My displacement, my displacement should be in this direction, specific direction. All right. So if you check this clearly, you're going to find that displacement is simply each and every length covered, all right, without direction, without considering the direction. But if we are talking about displacement, we've got to consider the direction. So uh, distance, let me use black. So distance can be, for instance, 2 meters, but displacement will need to be 2 meters east, north, west, or south to show that this is a vector and it has a specific direction, right? So that's basically the difference between the two, distance and displacement. Otherwise, they are both measured in meters, and to some extent, the formula I used interchangeably. So it's been Pearson, the science teacher. Thank you for joining.